Hi guys, welcome back for section 6.3. So this is going to kind of carry over from 6.2. So it's kind of going to be a little bit of a review almost. So if you're having trouble with 6.2, hopefully now with 6.3 it'll make more sense. So with these ones, we're used to having a 2x2 box, and we're used to having a parenthesis and then another parenthesis to give us the 2x2 box. This is the new part right here, the little 2. Okay, so that little 2 exponent, it means to do it twice. So instead of just having it once, we're going to do the exact same thing twice. So we're going to make a 2x2 box and leave a little bit of space so you can write up on top. Make your 2x2 box. You're going to fill in 3x plus 4, 3x and then plus 4. And then the new thing is you're just going to do it again, okay, twice. This means to do it twice, and you might want to write that down, twice. 3x plus 4. Okay, so you have the same thing here and the same thing here. You just have it twice. Okay, make sure you are taking notes. If you're not taking notes, you're not going to learn this. It's very, very hard to learn this without actually taking pencil and putting it to the paper. So please make sure you are taking notes. So we're going to do it twice. So we got it here once, got it here twice. Now we're going to fill in the boxes. Now again, before you start, if you prefer, just like in 6.2, every letter gets a coefficient and an exponent. Every letter gets a coefficient and an exponent, and then these obviously don't have any letters, so we don't need to worry about that. But if putting those little ones in there is helpful, go ahead and do that. If you don't need it, and you remember that the ones are there, then by all means, you don't have to spend any time putting them in there. But as you're first starting out, it's a good idea to have them in there. Okay? Now you're going to fill in the boxes the same thing like you did for 6.2. So multiply the big numbers. 3 times 3 is 9. Add the small exponents. 1 plus 1 is 2. X times x is x squared. Okay? So we're multiplying 3 times 3 and adding 1 plus 1. 3 times 4 is 12. Keep the x. 4 times 3 is also 12 because it doesn't matter the order. Keep the x. And then 4 times 4 is 16, and it's a positive 16. Okay? And then just like before, you're going to look for buddies. Okay? So the only thing that's here that has an x squared is this. 9x squared doesn't have a buddy. It's all by itself. But these are buddies. X goes with x and it stays in x. And we add. Make sure you write that down. Just like we did for section 6.2 yesterday. Okay? So now 12x plus 12x, we're going to add them together and we get 12 plus 12. It doubles to 24 and it stays in x. This is called a double diagonal. Anytime you have the 2 here and you're doing it twice, you're going to have a double diagonal. 12 plus 12 doubles to 24. And then you just keep the plus 16. Okay? So you still have the first term hanging out by itself. You still have the last term hanging out by itself. And that middle term is just doubling. 12 plus 12 is 24. Okay? I like to call these double diagonals. And then we're going to look at disappearing diagonals in a minute. You don't want to get those confused. So make sure you're always adding the diagonals. Okay? Same thing over here, but we have more than one letter. Okay? It's done the exact same way. It just has 2 letters, but totally done the exact same way. So we've got 2 things. So we're going to make a 2x2 box. Okay? And this just means to do it twice. Okay? So 5x and then the plus 2y, and then do it a second time. Do it twice. 5x plus 2y. Okay? I'm going to get rid of this just so we're not getting confused. Okay, bring this a little closer. There we go. So now, if we need to, we're going to put the coefficients and the exponents in. So every letter has a coefficient and an exponent. Coefficient, exponent, coefficient, exponent, coefficient, exponent. So they all had the coefficients. We just had to add the exponents. Now you're going to fill in the boxes. 5 times 5 is 25. 1 plus 1 is 2. Or x times x is x squared. 5 times 2 is 10, and it's x and a y. Those aren't the same letter, so we can't add the exponents here because they're different letters. X's go with X's and Y's go with Y's. So we have an X, Y, so we're just going to write it like that, X, Y, keeping it separate. Always do it in alphabetical order as well. So I put the X first because X comes before Y in the alphabet. If I had A and B, I would put A before B, and B would always come before C. It's always done in alphabetical order. Same thing down here. 2 times 5 is 10, and I have an X and a Y, so I put the X first and the Y second, so it's alphabetical order. And that way, if we all do it the same way, we'll all have the exact same answer. And then 2 times 2 is 4, but now we do have the same letter. Y times Y is Y squared. 1 plus 1 is 2. We can add those because they're the same letter. So now, just look and see if you have anything that buddies up for your final answer. So, x squared. I only see one thing with x squared. So 25x squared is just kind of hanging out there at the beginning by itself. These are the same. 10xy and 10xy. Remember, we add them. If you need to write that down to remember, go ahead and write that down. 10 plus 10 doubles to 20, and it stays xy. Just like from section 6.1. X goes with x, and it stays in x. X to the 5th goes with x to the 5th, and it stays x to the 5th. And xy goes with xy, and it stays xy. And then this last one, we're just going to write plus 4y squared because there's nothing to buddy up with that. Now, this is our final answer. So make sure that you don't just have this, but you have the final answer. And this is also a double diagonal. 10 plus 10 doubled to 20. Okay? So now I'm going to give you a couple to try on your own and see if you're understanding that. So we'll come back with a checkpoint in just a second. Okay, so now we're back for a checkpoint. So this time you're probably going to want to pause these or pause the video and write these down. We've got x plus 3 quantity squared. That's how we say that. Quantity, meaning the whole quantity is squared, not just the 3. And then 3m plus n quantity squared. Okay, the whole thing is squared. And that just means do it twice. So we've got a 2 by 2 box and we've got a 2 by 2 box. So go ahead and pause it, try these on your own. And then if you're still stuck, kind of follow along. If you try it on your own, just pause it, come back and try and see how we've done it. So you're going to put x plus 3 and x plus 3 twice, okay? Or 3m plus n and 3m plus n, okay? Depending on your problem. Now we're going to fill in the boxes. So at this point, if you want to put in your ones, you can. But if you don't need them, that's fine too. I know that x times x is x squared. Okay, I don't need the ones. But if I'd like to put in a 1 here and a 1 here and a 1 here and a 1 here, look what happens. 1 times 1 is 1. Do I need that 1? No, it's an imaginary 1. So I don't need it. And 1 plus 1 gives me 2. Okay, so you can do it with or without the imaginary ones. 1 times 3 is 3, or you can just do it without. 3 times x is just 3x. Same thing over here. 3 times x is 3x. And 3 times 3 is 9. Okay? So now you're going to look and see what buddies up. So we've got an x squared. These are the same. 3x plus 3x, we're going to add them. 3 plus 3 doubles to 6. This is a double diagonal. And then we just have plus 9. Okay, so these are called double diagonals because they're the same and they're doubling. Same thing with 2 letters. If we have an M and an N, it's going to work the same way. You're just going to have 2 letters in your answer, which is totally fine. 3 times 3 is 9. M times M is N squared. And again, if you need to throw the little ones in there, you can totally do that. 3 times MN is just 3MN. M and N don't go together. So we put M first because it's alphabetically before N. Okay? Just like A would go before B. 3MN here, same thing. And then N times N is N squared because there's 2 N's. Okay? So N times N, if you want to put the little ones in there, you would make it N squared. And that's because they're the same letter. So now look at what your buddies are. So we have a 9m squared with no buddy. We have a plus n squared with no buddy. But these two are buddies. They're both mn. Mn goes with mn and it stays mn. 3 plus 3 doubles to 6 and it stays mn. Another double diagonal. Okay? So anytime you see the parentheses and the whole quantity is squared, this means you're going to do it twice. And it also means it's a double diagonal. Okay? So if you haven't wrote that down, you're going to definitely want to have that in your notes. These notes are going to be helpful when you get to section 6.3 assignment, but they're really going to be helpful when we get to the test at the end of the chapter. And maybe, you've forgotten some of these. Those notes will be helpful to jog your memory. So make sure you're taking good notes. Okay, so that's double diagonal. We're also going to look at what I like to call a disappearing diagonal. So give me 1 second and I'll get those problems up and then we'll be done. Okay, so now we're going to look at example 2, which is all about what I call disappearing diagonals. So let me show you why it's a disappearing diagonal. So here you have t plus 5, so we can write t plus 5, and then t minus 5, t minus 5. Okay, so you can kind of see already a plus 5 and a minus 5 are going to cancel, and it's going to disappear. Okay, and the middle term is going to disappear, and we're going to have a disappearing diagonal. So anytime you see a plus and a minus, it doesn't matter which one's plus or which one's minus, it's automatically going to be a disappearing diagonal. Just don't get that confused with a double diagonal because they are a little bit different. If they're both plus or if they're both minus, then it's going to be a double diagonal. Okay? Now another little trick, guys, when I'm writing my t's, I normally when I'm just writing not in math class, I don't put a little hook on my t's, but in math class, I always put a little hook on them. Kind of like a little fish hook, so they don't look like a plus sign. Because if you're doing a problem that's like 5 steps long, it can start looking like a plus symbol, okay? So just make sure that's kind of why they look a little different. I do have a little curly Q on my T. Okay, but let's fill these in. So T times T is T squared. You can add the little ones if you want, and you can add the ones in front if you want. But 1 times 1 is still my imaginary 1, so I don't need that. And 1 plus 1 is 2, okay? Or I can just do t squared. 1 times 5 is 5, keep the t. Negative 5 times 1 is negative 5, keep the t. See how they're different? 5t and negative 5t. Those are going to cancel in a second. And negative 5 times positive 5 is a negative 25. Okay, so what's going to happen here is you're going to look at your diagonals. We don't need this imaginary 1. And these are what we call a disappearing diagonal. So we've got t squared. We've got the minus 25. But what happens here? What's 5t take away 5t? Or negative 5t plus 5t. Doesn't matter the order. It makes 0 and they disappear. And we only have the 2 terms. We don't have that middle term anymore. Okay, so this is called a disappearing diagonal. Okay? So now let's look at the next one. It works the same way when we have 2 letters. So we have an X and a Y, same concept. So we've got 3x plus y and 3x minus y. Okay? Now, if they were both plus or if they were both minus, that'd be one thing, but we have 1 plus and 1 minus, so we know we're going to be canceling in disappearing diagonals. Okay, 3 times 3 is 9, x times x is x squared. Now, if you need to put the little ones in, go ahead and do that, but I know x times x is x squared because I've done it enough. Once you've done it enough, you don't really need the imaginary ones anymore. 3 times xy. X comes before y in the alphabet, so I'm going to write it as 3xy, alphabetical order. Negative 3, and x comes before y in the alphabet, so it's going to be negative 3xy. And a negative times a positive is a negative. And what's y times y? If you want to add the ones, you can. 1 plus 1 is 2. But y times y is y squared. Now again, look at the diagonals. We normally add the diagonals, but what happens when we add these? What happens with a 3xy plus a negative 3xy? Or a negative 3xy plus 3xy? A negative and a positive eliminate or cancel or disappear is what I like to call it. So disappearing diagonal, we're only left with the 9x squared minus the y squared. Okay? So I'm going to go ahead and give you a couple checkpoints. We'll just do one checkpoint. And then if you're understanding it, we'll be good to go. And you should be able to do your 6.3 assignment. Okay, so this is the last one we're going to do. This is the checkpoint. At this point, go ahead and pause it. Write this down, pause the video, try it on your own. This is not a very difficult one. And then if you're still stuck, go ahead and follow along with me. So we've got 2 by 2. So I'm going to make a 2 by 2 Punnett square or box, if you want to call it. It's just like the Punnett squares you did in biology. Okay, so 2 by 2 box. Doesn't matter which one's on top and which one's on the side. So I'm going to put this one on the side, x plus 10, and this one on top, x minus 10. Again, doesn't matter which one goes where. So now I'm going to fill in the boxes. And at this point, I've done this enough where I don't need those ones anymore. So I'm just going to do x times x is x squared. X times negative 10, it's just like a 1 there, okay? So it's like negative 10x. This is like positive 10x. And 10 times 10, be careful. You're multiplying this. People forget and they try to add them. Make sure it's 10 times negative 10, which is negative 100. Okay? And again, now just look to see what buddies up or what maybe disappears in this case. So x squared, nothing to buddy up. Minus 100, nothing to buddy up. But negative 10 and positive 10, doesn't matter the order, 10 and negative 10 cancel, they disappear, and you're left with just x squared minus 100 as your answer. Okay, so these are just a special case from what we learned in 6.2. Most of the time, they're not going to disappear and they're not going to double. Most of the time, you're going to have two numbers here, like 2 plus 3, and you'd add them to make 5. Okay, but if you have the exact same thing here, they either double or they disappear. Okay, so if one's positive and one's negative, they're going to disappear. But if they were both 10, I would make it a double diagonal to 20. If they were both negative 10, I would double it to a negative 20. But since one's positive and one's negative, they make 0 and they cancel. Okay, so at this point, you should be good for your section 6.3 assignment. If you have any questions, once again, please reach out to me. Please let me know. I'm here to help. And then we're just going to be moving through section 6 pretty quickly.